Okay, so today we're going to solve equations with variables on both sides. Okay, so again, we're still solving for a letter, but we're going to have not only numbers or constants to move, but we're also going to have variables. Okay, so let's go ahead and just do a quick warm-up here. I know the answers are there, but basically all we're doing here is more practice of what we did yesterday. So on number 1, we're just grouping our like terms. So remember, when you subtract, remember you're going to do sort of like a keep, flip, change. And then signs are different, so you need to subtract. So 4x minus 10x would give us a negative 6x. On number 2, we're going to apply the distributive property. Now, notice on this one, when we distribute the negative 7 to the x, we just get negative 7x. But when we go over here to the negative 3, it's a negative times a negative, which causes it to become a positive. So when you're distributing a negative number, and there's a subtraction sign in that parentheses, be careful. Okay, number 3, we're going to distribute that 1/3 to the 6 and the 9. Now when we distribute it here, it's really 1/3 times 6x over 1. I can simplify on my diagonals and make this 2x. And then the same thing when I do the 1/3 times 9. Simplify diagonally and make it plus 3. So sometimes when you're multiplying by fraction, the fraction's going to go away if it goes in evenly. On number 4, be careful with that negative sign there, or that subtraction sign. Let's pretend like there's a 1 here. We're going to add it in. It's assumed to be there. And now you're going to distribute a negative 1 to the x and to the negative 2. So 15 minus x and then plus 2. And then I can group my like terms, the 15 and the 2, and that's how they got 17 minus x. Good on that? And then 5 and 6 are just a review of last night. All right, let's go on and let's see what our objective is today. Yes?
I can't find the notes.
Okay. Did you go to the module? Okay, so our objective today is to solve equations in one variable that's going to have a variable on both sides of that equal sign. Okay, we're going to encounter some identities. When we go to solve some of our equations, some of them are going to be identities. Some of them also may produce no solution. And we'll see some examples of these today. So to solve an equation with variables on both sides, we're still using inverse operations. And we're going to try to collect or group our variable terms on one side and our number terms on the other. It doesn't matter which way you move the letters. Okay, if you want to stay consistent and move letters left, because letters start with the letter L, you can, but it does not matter. Okay, so try to keep the coefficient positive. So if moving it to the left would make it negative, then move it right. It's okay. But you understand what I'm saying? We'll see in an example in a minute. All right, so here we go. Here is our first example. I'm going to rewrite it over here and write it from scratch. So I have 7n minus 2 is equal to 5n plus 6. So our goal here is to group the 7n and the 5n together. To get them together, I need to use inverse operations. So I'm going to move the 5n to the other side by subtracting it. from the right and from the left. It'll now give me 2n minus 2 is equal to 6. Now I have something that looks like what we've been doing for the past 2 days. It's a simple two-step inverse operation equation where we will now add the 2 to both sides, drop down the 2n, add 6 plus 2, and then divide by 2. And find out that n equals 4. Again, remember, you can check your answer. So I can take my original problem, the 7n minus 2 equals 5n plus 6. Right now, everywhere that I see the letter n, I'm going to now replace that n with the 4. So 7 times 4 minus 2, and then I'll put 5 times 4 plus 6. 7 times 4 is 28 minus 2 is 26. And then 5 times 4 is 20 plus 6 is 26. So because I got the same answer when I replaced it, it did work. My answer of n equals 4 was correct. Everyone good so far? Any questions? Let's try another example. Now on this example, 4b plus 2 equals 3b. Now for this one, we don't have a number to move. We just have letters. Now I can do this 2 ways. Now back, I think 2 slides ago, they told you to try to keep your variable coefficient positive. But I'm going to show you moving it left and moving it right and how you can still get the same answer. So if you do it like they showed in their example, they're trying to keep the b coefficient positive. So when they move the 3b over, you're now left with 1b plus 2 equals 0. I need to have the b all by itself. So now I still have another step. I subtract the 2, and now I find out that b equals negative 2. Now, you can do this same problem by moving the 4 to the 3. It doesn't matter which way you move it. In the end, you will still get the same answer. So if I move the 4 over to the 3 by subtracting it, I get 2 is equal to negative 1b. I can never ever have a negative variable, so I need to divide by negative 1. And I end up with negative 2 is equal to b. Notice it was the same answer no matter which way I moved my variable. You will always get the same answer. One of the steps are going to be different or both. Any questions on that? Okay. Here is another example, and now we have some decimals. However, the process is the same. I want to group or collect all my variables on one side and then group all of the numbers without letters on the other side. So if I take my original problem, the 0.5 plus 0.3y is equal to 7/10 y minus 3/10. I need to group the y's. Now again, they're trying to keep the coefficient in front of the letter y positive. So that's why they moved it to the right. So if I move the 3/10 y to the right, the 5/10 drops, the equal sign drops, And here I get 4/10 y minus 3/10. And then I'm going to add 3/10, giving me 8/10. So 0.8 equals 0.4y. I now divide 0.4 on both sides, the number with the letter. I will put the 8/10 inside the box and the 4/10 outside. Remember, you have to move it once here to make it a whole number. Move it once here. 4 goes into 8 2 times, and y equals 2. Good? Let's try another example. All right. Before we try another example, remember, you may have to apply the distributive property before we can begin the inverse operations. And then you may also have to combine some like terms first. Next example. This one looks like it's a big mess here. Let's look at this thing. Okay, we have 4 minus 6a plus 4a equals -1 minus 5 parentheses 7 minus 2a. So we've got to do a lot of things here before we can even begin to start our inverse operations. On the left side, what should we do first? Good. I'm going to combine my like terms, which happen to be the -6a and the +4a. When I combine those variables, what do I get? Ballroom. Good. So 4 minus 2a, because it's a -2a. Now, over here on the right side, I'm going to drop down my -1. Okay? I need to apply the distributive property here. And I need to be careful with my signs. Remember, take your time, watch your signs. Vincent, you want to help me out?
Sure.
All right.
The -5 distributes to 7, then it's -35 plus 10a.
Beautiful. Okay? Because you're doing a negative times a negative, and that's why the 10 becomes positive. Good. All right. One more step before I can begin inverse operations. What else do I need to do to that right side? Carlos.
Combine like terms.
Good. What can I get when I combine those like terms?
-36.
Wonderful. So -36 plus 10a. Now I can begin collecting my variables on one side and my numbers on the other. Now, which way you guys want to move that letter A, Vincent?
To where the 10 is.
Okay.
12a.
We're going to try to make it positive. Good. Now, you can move it left. It's okay. But we're going to move it over here so our letter A stays positive. And then I get 4 equals -36 plus 12a. All right, what's my next step? Let's see, Cyril.
We have to add 36 on both sides.
Perfect. I'm going to add 36 to both sides. I need to make this smaller again. Okay, so 4 plus 36 is 40 equals 12a. Now what's my last step? Somebody I haven't heard from this morning? I've heard from Cyril and Vincent and Carlos and Ryan. Anybody else want to attempt? Gilberto.
Divide 12
Good. Divide 12 on both sides. Now, right now, and I'll move it up here, A is equal to 40 over 12. Can I leave it like that? Joshua? Good. Okay, now, I'm okay with you leaving it improper, but we have to reduce it. What can we divide 40 and 12 by to make it smaller, to reduce it? Ryan?
2.
Okay, we could do 2. Is there a number we could do bigger? Okay, let's try 4. 2 would work, but then we'd have to do it again. All right, and sometimes when you see that they're even, that's a good starting place, is dividing them by 2. But if I divide them by 4, it's going to jump right all the way down to 10 over 3. Now, I'm okay with you leaving it improper, 10 over 3. If you prefer to make it a mixed number or a decimal, you would divide it. And 3 will go into 10 3 times with 1 left over. So 3 1/3. Or if you made it a decimal, 3.3 repeating. Pretty good so far? Now, if you're going to check your answer, I would plug it back in as the improper fraction. Okay, because you're going to be multiplying there. Any questions on this one? Had a lot of work. So when you're doing your homework tonight, I want to see all of these steps. I don't want to just see 10 over 3 on the line. I want to see the work. All right, here is the same problem, and they got 10 over 3. So it took 2 slides for them. All right, here's another one with fractions. Again, once you distribute, or even before that, if you prefer to find a common denominator and clear out the fractions, you can. But we'll go ahead and just work with the fractions. So first thing I'm going to do is distribute the 1/2 to both the b and the 6. So let me rewrite my problem. So I have 1/2, and then in parentheses, b plus 6 is equal to 3 over 2, b minus 1. All right, so I'm going to distribute the 1/2 to the b. Distribute the 1/2 to the 6. 1/2 of 6 is 3. And then I'm going to just drop down my right side. The 3 over 2b minus 1. All right, so now remember, we need to group our like terms. So I'm going to need to group the b's together. Which way you want to move that 1/2? Left or right? Vincent? Right. Okay, let's move it right so it stays positive. Okay, so we're going to subtract 1/2 b from both sides. And then 3 is equal to, and then when I subtract that, I actually get 2 over 2. When you have the same number on the top and the bottom of a fraction, what does that simplify to? Joshua? A whole number, just 1, right? So really all I'm left with now is b. So this one wasn't as bad as it looked. It looked kind of scary at the beginning, but once we subtracted that, we're just left with b. So now all we have to do is move the 1. So we'll add 1 to both sides, and I end up with 4 is equal to b. And it wasn't so bad. And again, you can always check it by plugging it back in. Here is an additional example. This time, you're going to group. Instead of rewriting, I'm just going to walk through the example that I've written. On the left side, you need to group your like terms, the 15 and the 9. Once they subtracted that, they got 6. They dropped down the 3. Over here, you have to distribute the 2 to the x and to the 2. Once they distributed that, they're now down here at this line. The 3x plus 6 equals 2x plus 4. So we're at this line. So now we begin our inverse operations. They're moving the 2 to the left side, and then they move the 6 to the right. And they end up with x equals -2. All right, now we're going to talk about an identity. And an identity is an equation that's true for all values of the variable. Okay, an equation that's an identity has infinitely many solutions. Okay, some equations are always false and they would have no solution. So what's going to happen for these two situations when it's going to be infinitely many or no solution? What's going to happen is the variables are going to cancel out. When the variables cancel out from both sides, if you're left with a number equaling itself, that's when you're going to have infinitely many. But if you get something that looks like nonsense, like 2 equals 3, if you're left with this in your problem, that's never going to occur. So that's when the situation would be no solution. And we're going to go through some examples. So when you end up with saying 2 equals 2, you know that's true. So then you're going to have infinitely many. What that means is no matter what number you plug in for the variable, it's always going to give you a true statement. When it's the no solution, no matter what number you plug in, it never works. And we're going to see some examples. All right, so here is the identity and false. It's just explained in words. So when solving an equation, if you get an equation that's always true, the original equation is an identity, and it has infinitely many solutions. So notice here, they've done it with numbers. 2 plus 1 equals 2, which equals 2 plus 1. And same thing if it's a variable. When you do a problem and you can clearly see that you're not left with a true statement, then you know it's no solution. So here's our first example. So we're going to solve it just like we did all of the previous examples. So I'm going to write 10 minus 5x plus 1 equals 7x plus 11 minus 12x. All right, so the first thing I need to do is see if there's any like terms or anything to distribute. Nothing to distribute, but I do have some like terms over here on this right side that I could group together. So 7x minus 12x gives me?
5x.
Okay, so negative 5x. Let me write it with the pencil instead of the highlighter. So negative 5x plus 11. And then over on this side, I have 10 minus 5x. All right, I want to try to group my letters together. So I need to move the 5x's together by using inverse operations. So I'm going to add 5x to both sides. Notice that on both sides of my equation, the 5x's cancel. And then I'm left with 10 equaling 11. Will that ever occur? Will 10 ever equal 11? No. So when you get something, did I write the wrong problem? A 1 there, thank you. Look at that. Thank you. So 1, so let me go back. Okay. There was a 1 here. So this is actually, when I group my like terms, let's change this up. Okay. Okay, so that changes my answer from no solution to infinitely many. Because once the variables cancel away, if you are left with the same number equaling the same number, then this would be infinitely many solutions. Okay, it's not going to matter what the value of x is. Vincent.
I was going to say, because I got 1 because I subtracted 10 from both sides and left the 1 there.
I made a mistake. See the 1? So you're going to group those like terms. So 10 plus 1 should have been 11. And then you got basically the same thing on both sides, which gave you an identity. Okay, it's like a mirrored image. All right, let's try the next example. This is the one where it's going to be no solution. All right, so again, be careful when you're rewriting your problem. Don't forget anything. Equals 5x minus 4 plus 8x. Okay, so I have like terms on both sides of my equal sign. I've got a 12x and a 1x that I can group on the left side. And then I have a 5x and an 8x on the right side. So 12x plus 1x gives me, somebody? 13x minus 3 equals 8 plus 5? 13. Okay, I now need to group my letters. So I will subtract 13 from both sides, leaving behind -3 equaling -4. Will that ever occur? No, it will not. So there is no solution to this equation. So when the variables cancel away and you're left with an answer or the numbers that do not equal each other, it's no solution. All right. Here's another example. Again, after they grouped all their like terms and then used their inverse operations, they were left with 7 equals 10. This will never occur, so there are no solutions. So we're going to still solve all of the problems the same way. We just have to be able to interpret our answer. So if the variables cancel away and it's a true statement, it's infinitely many. But if it's a false statement, it's no solution. Here is an example of you're getting a true statement. So then this means, now some books will teach it to you as you would say all real numbers, because it doesn't matter what real number you put in there, it works. Or you could also tell me the infinitely many. So I would accept either answer of infinitely many solutions or all real numbers. Either description of the answer. Here is an application problem. It says that John and Sarah are planting tulip bulbs. John has planted 60 bulbs and is planting at a rate of 44 bulbs per hour. Sarah has planted 96 and she's planting 32 bulbs per hour. And it wants to know in how many hours will John and Sarah have planted the same number of bulbs. So they've organized the information, John with his 66 and 44 per hour, and Sarah 96 plus the 32 per hour. So they've laid out their information. Now we're going to come up with the equation. So we're going to set the two things equal to each other. You'll put each person's information on one side of the equation and then begin your inverse operations. So this would be the number of bulbs and then the rate that they could plant them. The bulbs and the rate. Set them equal to each other and then solve. We will subtract 60 first and then divide by 12. So after 3 hours, John and Sarah will have planted the same number of bulbs. Okay, and they would have each planted 192 bulbs. Here is another application example. You can read through it. I think the bell's going to ring soon. Then they've solved it, and then there's a few more examples at the end. Your homework is on Canvas. It's due Tuesday. There's no school Monday. Okay, it must be turned in. Any questions? Okay, perfect. All right, you can start it for a few minutes.